Jai Hind everyone. Today let's continue the chapter 3 of NCERT Class 11 Physical Geography, that is Interior of the Earth. Today we are starting with Structure of the Earth. Let's see the topic. So in Structure of the Earth, let's see the diagram of the Earth. If you see here, the upper portion is called crust, and the next portion that comes after the crust is called mantle, and the center of the Earth is called core of the Earth. In this, we'll learn different types of segregation based upon and their names also. Let's see. The crust. It is the outermost solid part of the earth. It is brittle in nature. So what is the crust? It is the outermost solid part of the earth and it is also brittle in nature. The thickness of the crust varies under the oceanic and continental areas. The oceanic crust is thinner as compared to the continental crust. The mean thickness of oceanic crust is 5 kilometers, whereas that of continental is around 30 kilometers. So the continental crust is thicker than oceanic crust, where the average thickness is around 30 kilometers for continental crust, whereas for oceanic crust, it's just 5 kilometers. The continental crust is thicker in the areas of major mountain systems. It is as much as 70 kilometer thick in the Himalayan region. So this is the first outermost part that is called the crust. And then next that comes under the crust is the mantle. The portion of the interior beyond the crust is called the mantle. The mantle extends from Moho's discontinuity to a depth of 2,900 kilometers. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 kilometers. The mantle is the main source of magma that find its way to the surface during volcanic eruptions. The crust and the uppermost part of the mantle are called lithosphere. The thickness ranges from 10 kilometers to 200 kilometers. The lower mantle extends beyond the asthenosphere and it is in solid states. Let's see the division between mantle. If we see here, this is the crust and the portion that starts beyond the crust is called mantle. And what is Moho's discontinuity? Moho's discontinuity basically is the boundary between crust and upper portion of the mantle. So in mantle, we have two divisions, that is upper portion and lower portion. So Moho discontinuity comes between crust and upper mantle. And asthenosphere. The upper portion of the mantle is called asthenosphere, which extends up to 400 kilometers. And asthenosphere is the main source of magma. It is also the weaker section of mantle. And then comes the lower section. The lower section is basically in solid state, whereas the asthenosphere is in semi-solid state. The crust and uppermost part of the mantle are called lithosphere. Its thickness ranges from 10 to 200 kilometers. So here, if you see, this is the crust and this is the asthenosphere. So here we have Moho's discontinuity, that is the boundary between crust and upper mantle. The next one is core. What is core? It is the distinction that comes beyond the mantle. As indicated earlier, the earthquake wave velocities helped in understanding the existence of core of the earth. The core mantle boundary is located at the depth of 2,900 kilometers. The outer core is in liquid state while the inner core in solid state. The core is made up of very heavy material mostly constituted by nickel and iron. It is sometimes referred to as the NIF layer. So, the crust, which is basically continental and oceanic crust, the average thickness can be varied from 5 kilometers to as much as 70 kilometers in the Himalayan region. And then starts the mantle, which extends up to 2,900 kilometers. In mantle, we have two divisions, that is upper portion, which is called asthenosphere, and the lower portion. While the upper portion is semi-solid and the lower portion is solid in state. And then comes the core, which also has two divisions, that is the outer core, which is in liquid state, and the inner core, which is in solid state. Now let's learn the discontinuity names between different sections. The first one we have is Conorrod discontinuity. Where is the Conorrod discontinuity? It is along the boundary of upper crust and lower crust. Even in crust also we have distinct divisions, that is upper crust and lower crust. And Conorrod discontinuity is between upper crust and lower crust. And then we have Moho discontinuity or Mohorevic discontinuity, which is between lower crust and upper mantle. And the third one is repeated discontinuity. It comes between upper mantle and lower mantle. So upper mantle, which is asthenosphere, and the lower mantle, which is solid, which is in solid state. So repeated discontinuity comes between upper mantle and lower mantle. And then we have Gutenberg's discontinuity, which is between lower mantle and core. So this is basically the basic distinction between mantle and core. So the Gutenberg discontinuity comes between lower mantle and outer core, whereas Layman's discontinuity is the last one, which comes between outer core and inner core. So let's revise the discontinuities. These are the first one, Conorrod discontinuity, which comes between upper crust and lower crust. And then we have Moho or Mohorevic discontinuity, which comes between lower crust and upper mantle. And then the third one is repeated discontinuity, which comes between upper mantle and lower mantle. And then we have Gutenberg's discontinuity, that is between lower mantle and outer core. And then the last we have Layman's discontinuity, which comes between outer core and inner core. So these are the discontinuities, and these are the structure of the earth, where the outermost is the crust, which where the thickness is around 0 to 100 kilometers. And then we have mantle, that is until a depth of 2,900 kilometers. And from there we have the core, which extends up till 6,378 kilometers. This is the structure of the earth. And the next topic we have is volcanoes and volcanic landforms. You may have seen photographs or pictures of volcanoes on a number of occasions, where a volcano is a place where gases, ashes, and or molten rock material, that is lava, escape to the ground. A volcano is an active volcano if the materials mentioned are being released or have been released out in the recent past. The layer below the solid crust is mantle. It has higher density than that of the crust. In the indirect resources, we have learned that as we go from surface to the deeper depths, the density of the material increases. The mantle contains a weaker zone called asthenosphere. It is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion is called magma. Once it starts moving towards the crust or it reaches the surface, it is referred to as lava. So if the molten rock material is inside the crust, or it is in the upper mantle portion, it is called magma. But when it reaches the surface, it is called lava. The material that reaches the ground includes lava flows, pyroclastic debris, volcanic bombs, ash and dust, and gases such as nitrogen compounds, sulfur compounds, and minor amounts of chlorine, hydrogen, and organs. So these are the materials besides lava that comes out and reach the surface of the earth when a volcano erupts. So this is the basic explanation of volcano. And then we have different types of volcanoes. Volcanoes are classified on the basis of nature of eruption and the form developed at the surface. Major types of volcanoes are as follows. The first one is shield volcano, sorry. Barring the basalt flows, the shield volcanoes are the largest of the volcanoes on the earth. So basalt is in basic nature. So we know acidic and basic. So basalt is a basic nature. So the shield volcanoes, they are spread over larger areas. These are the largest of all volcanoes on the earth. In the basalt, it has less explosivity, but it has fluid lava. One of the examples of shield volcanoes are Hawaiian volcanoes, which are the most famous examples. These volcanoes are mostly made up of basalt, a type of lava that is very fluid when erupted. For this reason, these volcanoes are not steep. They become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. So, what is the condition in shield volcanoes? Uh, when erupted, there is less explosivity, but if somehow the water goes into the vent, it can become very explosive. The upcoming lava moves in the form of a fountain and throws out the cone at the top of the event at the top of the vent and develops into cinder cone. So, what happens when water gets into the vent? It it throws itself like this, and what happens? The roof or the vent collapses and becomes a bigger depression, causing a cinder cone. So this is the meaning for cinder cone. And next we have composite volcanoes. These volcanoes are characterized by eruptions of cooler and more viscous lavas than basalt. So it basically has acidic lava. These volcanoes often result in explosive eruptions along with lava. Large quantities of pyroclastic debris, material, and ashes find their way to the ground. This material accumulates in the vicinity of the vent openings, leading to formation of layers, and this makes the mounds appear as a composite volcanoes. Just a minute. So in composite volcanoes, we have cooler and viscous lava, and it is also in acidic in nature. These volcanoes are generally very explosive. Which volcano? Composite volcano. So in composite volcanoes, along with lava, we have pyroclastic debris that get settled on the ground. And due to that settlement of debris, ashes, and everything, this leads to formation of layers. So that is why these are called composite volcanoes, or also stratovolcano. Then another name for composite volcano is stratovolcano. And the next one is calderas. These are the most explosive of the Earth's volcanoes. They're usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depressions are called calderas. Their explosiveness indicates that the magma chamber supplying the lava is not only huge, but it is also in close vicinity. So, in calderas, what happens if we th- if we assume this as an explosive volcano, this lava gets erupted so much that the roof of the volcano collapse and becomes a greater depression. So then it forms something like caldera. So this is the meaning of calderas. Why do calderas form? Because of more explosive nature of the earth's volcanic eruption. So this leads to the collapse on themselves, and the collapsed depressions are called calderas. We have seen one in shield volcanoes also, that is cinder cone. When does it happen? When any water gets into the vent, it becomes explosive, and the lava uh, throws out of throws out the cone at the top of the vent and develops into cinder cone. And this is the calderas. And the next one we have flood basalt provinces. These volcanoes outpour highly fluid lava that flows for longer distances. Some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. There can be a series of flows, with some flows attaining thickness of more than 50 meters. Individual flows may extend for hundreds of kilometers. The Deccan Traps from India, presently covering most of the Maharashtra plateau, are a much larger flood basalt province. It is believed that initially the trap formations covered a much larger area than the present. So, the Deccan Traps of Maharashtra is an example of flood basalt flow or basalt provinces. And the next one we have is mid-ocean ridge volcanoes. These volcanoes occur in the oceanic areas. There is a system of mid-oceanic ridges more than 70,000 kilometers long that stretches through all the ocean basins. The central portion of this ridge experiences frequent eruptions. So these are the types of volcanoes. The first one is shield volcano, where the lava is less explosive, but the fluid lava. Example is Hawaiian volcanoes, and then we have composite volcanoes, and then we have calderas, and the last one is flood basalt provinces and mid-ocean ridge volcanoes. And then we have volcanic landforms, which are intrusive. That is, they form inside in the interior of the earth. These volcanoes, they form on the surface of the earth, but the next what we are discussing are going to form inside the earth. So that these are called intrusive forms. The lava that is released during volcanic eruption on cooling develops into igneous rocks. So the cooling lava solidifies to form igneous rocks. The cooling may take place either on reaching the surface or also while the lava is still in the crustal portion. So when the magma when it is coming to reach the surface on the of the earth, it sometimes gets trapped in the crustal portion and gets solidified to form various intrusive forms. Depending on the location of the cooling of the lava, igneous rocks are called volcanic rocks and plutonic rocks. If the rocks are formed at the surface, they are called volcanic rocks. But if the rocks are cooled in the crust only, then they are called plutonic rocks. This is the basic difference between types of igneous rocks. And then the lava that cools within the crustal portions assumes different forms. These forms are called intrusive forms. Some of the forms are shown in 3.4. Here we have, if you see, this is the batholith, this is the bedrock, if you have to say, and then we have sills, laccolith. We'll read in detail. Batholiths, a large body of magmatic material that cools in the deeper depth of the crust, develops in the form of large domes. They appear on the surface only after denudational processes remove the overlying materials. They cover large areas and at sometimes assume depth that may be several kilometers. These are granitic bodies. Batholiths are cooled portion of magma chambers. The first intrusive form is batholith, which is a large dome covering a much bigger area, and these are cooled portion of magma chambers. And the laccoliths, these are dome shaped. If you see in the picture, this is the laccolith. If you see, this is laccolith, which is dome shaped. Laccoliths are large, dome-shaped intrusive bodies with a level base and connected by pipe-like conduit from below. It resembles the surface volcanic domes of opposite composite volcano. Only these are located at deeper depths. It can be regarded as the localized source of lava that find its way to the surface. The Karnataka plateau is spotted with domal hills of granite rocks. Most of these now exfoliated are examples of laccoliths or batholiths. So, a laccolith is a dome-shaped body with its base being leveled and connected by pipe-like conduit from below. It also resembles the surface volcanic domes of composite volcano. One of the examples of laccoliths is Karnataka plateau. And then we have lapolith, phacolith, and sills. As and when the lava moves upwards, a portion of the same weight tend to move in a horizontal direction wherever it finds a weak plane. It may get rusted in different forms. In case it develops into a saucer shape, concave to the sky body, it is called lapolith. So what is a lapolith? Opposite to laccolith. So if the lapolith forms a dome shape, laccolith forms a dome shape, lapolith forms a saucer body to the crust surface of the earth. It is a concave body to the sky. A wavy mass of intrusive rocks at times is found at the base of synclines or at the top of anticline in folded igneous country. So this is phacolith. Such wavy materials have a definite conduit to source beneath in the form of magma chambers. These are called phacolites. So laccolith is dome-shaped, lapolith is saucer-shaped or concave-shaped to the sky, and whereas phaccolith is a wavy-shaped. And the next we have the near horizontal bodies of the intrusive igneous rocks are called sills or sheet depending on the thickness of material. The thinner ones are called sheets while the thick horizontal deposits are called sills. Let's see what they are. Here, if we see, this is the horizontal part. If it is a vertical part, then we have another name called dike. But if it is horizontal, we call it either sill or sheet. If it is thinner, then it is called sill. But if it is thicker, then we call it as sheet. So these are the horizontal chambers. Sorry. And then the last one is dikes. When the lava makes its way through cracks and the fissures developed in the land, it solidifies almost perpendicular to the ground. It gets cooled in the same position to develop a wall-like structure. Such structures are called dikes. These are most commonly found intrusive forms in the western Maharashtra area. These are considered the feeders for the eruption that led to the development of Deccan traps. So if we have bodies that are horizontal, then we call them as sills or sheets. But if it is perpendicular to the ground, then we call them as dikes. So this is the entire chapter 3 of physical geography, that is interior of the earth. Let's have a quick overview of whatever we studied here. First, we learned about sources of information, that is direct sources and indirect sources. In direct sources, we learned earth materials, volcanic eruptions. And in indirect sources, the first one is properties of matter. The second one is meteors. And the next are gravitation, magnetic, and seismic activity. Out of these, seismic activity is important. So we have studied in detail the earthquake. Why does an earthquake occurs? The earthquake waves and their properties, and how studying of earthquake waves helped in structuring the interior of the earth. And then we have studied types of earthquakes, how are they measured, and the effects of earthquakes. And then we have studied structure of the earth, where the outermost portion is called crust, and then comes the mantle, and then comes the core. We have learned the discontinuities between each portion, and then we have learned volcanoes, types of volcanoes, and the intrusive forms also. So this is all about chapter 3 of NCERT Class 11 Physical Geography. We'll meet in the next class. Thank you.